Hey folks, Ms. Gosling here with a slightly more difficult thermal physics problem. In this problem, we're going to figure out how much energy it takes to turn 5 kilograms of water at room temperature, so 20 degrees Celsius, completely into steam. The boiling point of water is 100 degrees Celsius. Its specific heat is 4.19 kilojoules per kilogram Kelvin, and the latent heat of vaporization for water is 2,230 kilojoules per kilogram. We are trying to figure out how much energy, again, it takes to turn this water completely into steam. In order to start this problem, I am going to go ahead and draw the phase diagram for this water. So we have heat on the x-axis, and that's going to be measured in kilojoules, and we have temperature on the y-axis measured in degrees Celsius. And our water starts here at 20 degrees Celsius. What we're going to do is we're going to first heat the water up until it reaches its boiling point, 100 degrees Celsius, because it's not going to turn to steam until it reaches that temperature. So that's going to be the first step of our problem. The second part of our problem is figuring out how much energy it then takes to turn our 100 degrees Celsius water completely into steam. So that's going to be the second part of our problem, and I'm going to go ahead and write in part 1 and part 2 here, so that way you can see what's going on. So now that I have a picture of what's happening energetically with this water, I can go ahead and start solving the problem. So I know that I can list my givens out. I'm going to start by listing them out for part 1. So for section 1, the mass of my water is 5 kilograms from here. And the water is going from its initial temperature of 20 degrees Celsius to its final temperature of 100 degrees Celsius. I also know that its specific heat is 4.19 kilojoules per kilogram Kelvin. So those are all of my givens for this first section of my problem, where we're heating the water up. Now let's go ahead and do my givens for the second part. Again, my mass is still 5 kilograms. That's not going to change. But now, I'm not changing my temperature at all, right? You can tell because this is a flat line. All of that energy is going into breaking the bonds between the water molecules to turn it from a liquid into a gas. And so we're going to use that latent heat of vaporization, the latent heat of vaporization for water, which is 2,230 kilojoules per kilogram. So now I have all of my givens, and I'm ready to list my unknown. And again, I highlighted my unknown in red here. I'm trying to figure out how much energy it takes to transform this water into steam. So my unknown is going to be Q, which is our heat energy. So let's go ahead and write our equation. So we have Q. That is going to equal the heat required for the temperature change, so I'm going to call that Q1, plus the heat required to turn our water into steam, Q2, or, and perhaps a little more familiarly, Q is going to equal MC delta T plus ML. And we're going to put in that V for that latent heat of vaporization. And that is going to be my equation. What's really nice is that Q is already on its own, which means I don't have to do any manipulating to move on before I move on to the substitution step. So let's talk about our substitution step. Let's go ahead and substitute in our numbers. Again, Q is our unknown, so it's going to stay the same. Our mass is 5 kilograms. C is 4.19 kilojoules per kilogram Kelvin. And then my change in temperature is going to be T final, 100 degrees Celsius, minus T initial, 20 degrees Celsius. And to that, I am going to add my mass again, so 5 kilograms, times my latent heat of vaporization, which is 2,230 kilojoules per kilogram. And that is my expanded equation. So now I'm ready to go ahead and finish up by solving. So Q is equal to the heat required to raise the temperature of my water from 20 degrees Celsius to 100 degrees Celsius, which is 1,676 kilojoules. And you guys can double check the units, right? We've got kilograms and kilograms and degrees Celsius, which are going to be the same here as Kelvin. So everything's going to cancel out to kilojoules. And so again, I have the heat required to raise my water's temperature from 20 degrees Celsius to 100 degrees Celsius, 1,676 kilojoules. And to that, I am going to add the amount of energy required to to evaporate all of that water and turn it into steam, which is 11,150 kilojoules. And again, you can check your units here. So, all I need to do now is add those two numbers together. Excuse me. And when I do that, I will find that the heat required to complete this full operation is 12,826 kilojoules. Or, if we're using sig figs, Q is equal to 10,000 kilojoules, because we've got one sig fig here with our 5 and our 20 and our 100. And there you have it, folks. You now know how to solve problems that require you to both change the temperature of a substance and change its phase. So you can combine what we learned with Q equals MCAT with what you've also learned with Q equals ML. So now it's your turn to give it a try. Happy solving!